What does that mean? What's the greatest common factor? Good. The biggest number that can go into all those numbers. Only this time we're going to not only deal with the number, we're also going to deal with maybe power of the variable too. But the hard part, the variable part is really simple. Very simple. The hardest part, and it's not super hard, but the hardest part is going to be finding the number, right? So let's take this example here. We've got 36 x cubed minus 24 x squared minus 18x. So if we wanted to factor out the greatest common factor, what we're going to do is we're just going to rewrite this as some number or number and variable out front times whatever would be left over after we undistribute it. Because that's really all we're doing. When we factor out a greatest common factor, that's really just undistributed. So what is the number part? What's the biggest number that divides into 36, 24, and 18?
9, well, 3.
3 does go into all of them.
6.
6 is the biggest one though, isn't it?
I skipped it.
So
3 and 9.
we can pull out a 6. Let's just deal with the number part first. So if we factor out a 6, undistribute a 6, what numbers are we left with? What number would end up being left over in the first term?
6.
6, because 6 times 6 is 36,
Oh, that's what we're doing.
right? What number would be left in the second term?
3. Oh.
Negative 4, right? Because positive 6 times negative 4 is negative 24. And then the last one, negative 3, because 6 times negative 3 is negative 18. Okay, what about the variable part? There's two ways we can look at this. I'm going to write it down one way. That you're not going to do it this way, but I just want to illustrate why we get the answers we do. Just by way of just a little bit of quick review here. So this first one we could really write as 36 times a string of 3 x's multiplied together is x cubed, right? And minus 24x squared is just x times x minus 18 times x. Well, if I'm undistributing, what's the largest number of x's that I could undistribute from all 3? 1, right? This one's only got a single x to give, right? And so we're going to get an x out front with our 6. Now if we do that, what are we left with? Well, if I undistribute one of those x's, then that's what I'm left with, right? So how much am I left with here? X squared. How would I get that if I weren't writing it out this way? What did I do to get the 2 there? What's the power of x here? If we undistribute or factor out an x is really to what power? To 1, right? So if I'm factoring out an x to the 1, how did I get the 2? If I started off with x cubed. I just subtracted, don't I? Right? I'm just subtracting 1 from 3 to see what power of x is left over, right? And we know that. That's one of our rules of exponents that we'll review in detail later. But you talked about it in Algebra 1 also, right? Think about it the opposite. X to the 1 times x to the what equals x cubed. Well, we know that if we multiply like bases, meaning if we multiply powers of x, right? But x is what we're taking to the exponent in both cases. If we multiply like bases, what do we do to the exponents? Add them, right? So x to the 1 plus x to the what equals x cubed, x squared, right? And then the same thing here, I'd end up with 24x because I'm subtracting 1 from 2, right? And I got 1 left over. And then over here, nothing, right? Because we undistributed the x that originally started with the 18, right? So this is how it would look in factored form, right? But we don't even ask for that. Moodle wants nothing that complicated. All it's looking for is just what is the greatest common factor, which is that, 6 times x, right? So that's all you put in Moodle, 6x. Okay, try another one real quick. How about okay, what about that one? Everybody try it on your own first. Remember, number part first and then power of x. Okay, what's the biggest number that goes into all those? Chase, what do you think? What's the biggest number that divides evenly into negative 20 and 8?
8, I guess.
8 goes into 8. Does 8 divide into 20 evenly? Doesn't, does it? So, anybody got a different suggestion?
4.
4, okay, 4 goes into both, right? Does that make sense? So 4 is the number, but if I put in a 4 here, I'm going to get back some feedback that says, no, it's the wrong sign. Because there's a rule with this. We always want to, whichever is the dominant term, meaning whichever is the term that has the biggest power of x, whatever the sign of that number is, that has to be the sign of the GCF, the greatest common factor. So if that first term, the dominant term, we call it the leading term, is negative, then the greatest common factor should be negative. So we're going to have a negative. The 2 part is correct, though. So we've got, or 4, sorry. The 4 part is correct. 4 is the biggest number. What's the biggest power of x that I could undistribute from both of those? X to what power? 3. Yeah. Because each of those has at least one x in them. Well, the smallest one, the weakest one, has an x cubed. So that means I could undistribute all of that x cubed from everything, right? So if I did that stuff, so my answer is going to be negative 4 x cubed Oops. Okay, question. Yeah, you got a question.
Like, I don't know how, I don't understand the power.
The power part. Okay, so the rule is just going to be when we're factoring out a greatest common factor, all I'm ever going to look for is I'm going to be able to factor out the smallest common power of x, right? Each of these, only 2 terms. Each of the 2 terms has an x in them, so I can factor out a power of x, but I can't take any more than the wimpiest one can give me, right? The weakest one has x cubed, and so that's all I could undistribute.
But 3 can't go with
It can't, you're right. So let's see what we're left with if we do that. So we start off with negative 20 x to the 5th plus 8x cubed. And you told me that the biggest number that goes into both of those is negative 4, correct? Okay, so let's write what's left over. So what's left over? Negative 4 times what is negative 20? Positive 5, okay. Negative 4 times what is positive 8? Negative 2. Now let's deal with the powers of x, right? So if we take out an x cubed, what I want to know is what power of x is left over with the 5. In other words, x cubed times what is x to the 5th? Think about what this means. An x cubed is a string of 3 x's multiplied together, right? So a string of 3 x's multiplied together times a string of how many x's would give me a string of 5? 2, right? And so the answer is going to be x squared. And remember, what has to happen is these 2 numbers have to add up to 5, right? When they're exponents, right? When you multiply like bases, you add the exponents, right? So then what's going to be left over here? Well, I took all of them away, didn't I? Right? So I'm just left with this, okay? We don't care about what's left over in this problem. In this problem, all we want is that. Okay? Negative 4x cubed.
And then how did you get the
I got the negative 4 just because we asked ourselves what's the biggest number that goes into 20 and 8, and the answer was 4. But because the x to the 5th term, the term with the biggest power of x, was negative, that needs to be negative also. Okay. You'll see why that's the case later. Okay, for now, we'll just call that a rule, and later on, when we actually start putting this into practice and solving quadratics, it'll make sense to you why we did that, why we always factored out that negative.
So will it always be the less number for the power? Like, the smallest number?
Yes,
Okay.
it will, exactly. So one more, real quick. How about like, okay. So real quick, what's that one gonna be? Everybody just try that. Is the greatest common factor gonna be positive or negative? It's gonna be negative, isn't it? Lacey, what's the biggest number that divides into 42 and 12? What is it? Okay. It's 6, you're right. You're right, 6. Okay, and then Bailey, what's the biggest power of x that I could undistribute? Yeah, just x. That's it. Okay, negative 6x is the answer. Oh, what did I do? What did I do? That's right. 6 times 7? I don't know. I'll have to check that, see what's going on. Did anybody have that happen to them?
This is practice. Is this chapter 3 or 2?
This is chapter 3. Anybody have one of these not work? These should all work. Just curious. I just want to see something. I'll go back and see what's going on with that. I'll fix those. If it happened to you, flag it, and I'll give you credit. And I can regrade them too, so it'll give you credit. What about these then? The factoring simple quadratics. Let's look at a couple of these. So now these are the ones where all we're trying to do is we're trying to break this apart into a product of two simple factors, right? So we talked a little bit about this. It would have been last Wednesday.
Yeah, where'd you go?
I got surprised.
Yeah.
I got surprised. I went to Stanford for the weekend. So yeah,
So we're supposed to say happy birthday?
What's that?
We're supposed to say happy birthday?
You don't have to say happy birthday. My birthday's not until the end of the month, but for some reason, this was the weekend that worked. So I got kidnapped. All right, so let's have a look here. What about something like this? So our goal is to factor this, right? And let's just take a second and ask, why would we factor this? Okay, the reason we would factor this is to solve an equation. Now that's coming up, right? That's what this chapter is about. This is really just review stuff for the chapter. In the chapter, we're not going to worry so much about doing things like just factoring. Instead, we're going to try to solve the equation x squared plus 3x plus 2 equals 0. But remember what the problem was we talked about on Wednesday. We can't just isolate an x there, right? So our old strategy doesn't work. We've got to do something different. And so our goal, didn't I do some goofy where I had you guys multiply the numbers together, right? It was really an impossibly hard answer, but the answer was 0, right? I did that right. Okay, because, why was it 0? Because we multiplied by 0, exactly. Yeah, okay, we did that. Yeah. So our goal then is we just want to be able to break this into factors so we can play that trick, right? So we can use the zero product property and find the solutions by setting each little tiny easy factor equal to 0 and finding the value of x that makes that happen, right? Okay, but the process that I want to review is just how do we do that, right? If we're trying to break this up into factors, well, if it works, and we'll find out it doesn't always work, but when it does, it's really simple. It has to look like this. Now, what's my template look like here? Mallory, before I do anything, what can I write down before I even start thinking? Yeah, I've got x there, and the question really is just what are the numbers that I would combine with the x's to get this, right? So the pattern was, whatever those magic numbers are, they're gonna have to multiply to what? You're gonna always gonna multiply to the constant, right? So they have to multiply to end up being whatever that number is. And they have to add to what? Yeah, they're gonna add to whatever the coefficient of x is. So they're gonna multiply to positive 2 in this case, and they're gonna add to positive 3. Well, what are those numbers? What two numbers multiply to positive 2 and add to positive 3? 2 and 1, yeah. So the answer is just plus 2 and plus 1. Now, if we were, that's the answer we want in Moodle for this assignment. I just want you to write it in factored form. Starting, like tomorrow, when we start actually doing some math with this, we'll solve the equation like that product equals 0 when? What's going to be the value of x that makes this factor 0? -2, right? -2 plus 2 would equal 0, and so one solution would be x equals -2. What's the value of x that would make this factor 0? Because that's the only way I can get 0, is by multiplying by 0. So either that factor has to be 0 or that one does. What's this one going to be? -1, right? Those are my answers. But this is all I want in Moodle, just that. That's factored form. Okay? One more of those. How about? Okay, let's find a little harder one than that. How about? There we go. How about that one? Okay, so I can write my template. X and X, right? Okay, so what do the numbers have to multiply to? -80, okay, and add to positive 2. So let's play the number game then. If they're going to multiply to a negative, two numbers multiply to a negative, what can you tell me about the signs of the numbers? One's positive and one's negative. Now, which one's going to dominate? Which one's bigger if they add to a positive? The positive one, right? The positive one has to have been the bigger number, so let's always put that first. Just so we have a convention going here, so we always do have the same kind of approach to this. What would they be?
8 and 10.
Yeah, so which is the positive one? 10. So that's all we're looking for then, right? Okay. And then last one. What about something like that? That looks pretty bad. So if we're going to write that in factored form, yikes, we don't have just an x squared this time. We've got something else out front. Okay, these, and I talked about this before. Remember, we're going to have different ways of doing this. We don't necessarily have to factor these, but because you guys already know how to do bottoms up, if you need bottoms up, we'll review that real quick. Okay, so first question is, do we need bottoms up here? Right? Do we need bottoms up here?
Yes.
I'm hearing some yeses. Do you agree with them? Okay, it looks like we do because I've got a negative. I've got a number out here in front instead of x squared, right? But does anybody see a trick to make this easier? Bottoms up is a little bit difficult. If we can avoid it, we will. What do we always want to try to do first?
Simplify.
Yeah, I guess. But I mean, what do you mean simplify? What? Say it again. See if there's a greatest common factor that we could factor out. Is there something that goes into all of those terms? There is, right? What would we say the greatest common factor of that is? We just worked at some stuff like this. We did a couple sample problems. Okay, but it's going to be 2 or -2 because the leading term is negative, right? So we could rewrite this then as -2 times, and we don't even have to put parentheses around that. It's just one thing, right? Whoops. So what's going to be left over if we do that? What goes here? So -2 times, can I take out any x's, Bailey?
No?
I can't because that one doesn't have any, right? Okay, so there's nothing, we take out the smallest one. You asked that question, it's a good question. And that's what we do, but if one of the terms doesn't have any, then we can't factor any x's out, right? So all we can take out is a negative 2. Now what's left over? Negative 2 times what is negative 2x squared? X squared. Negative 2 times what is positive 18x? Negative 9x, right? And negative 2 times what is negative 36? Yeah. Everybody agree? Okay, look what we did. This made it easy. We've got the negative 2 out front, but now we don't need bottoms up. This is just a regular kind, right? So we can write our template. Now we've got that negative 2 out front. But our template really is just working on factoring the other factor, right? The one with an x squared. So what are my magic numbers going to be? They have to multiply to what, Emma? What do my magic numbers have to multiply to if I want to take this thing and break it apart? 18. Good. So you got to multiply to 18 and add to negative 9, right? So what are the signs going to be of the 2 then? Negative, right? Because they got to multiply to a positive, so same sign, but add to a negative. So what 2 numbers are they? What numbers multiply to 18, add to negative 9? Negative 3 and negative 6. Good. And so that's my answer. Now it's wrong if I don't include the negative 2, because when we write this in factored form, it means that if I were to undo everything I did, if I were to multiply this whole thing out, I'd have to get this answer, right? So the negative 2 does have to be there. Okay? All right. And then I guess there's one more I do want to do. I lied. Last one, though. Okay, what about this one? Can I factor out a greatest common factor this time? I can't, right? There's nothing that goes into 11, 45, and 4. 11's prime. What's it mean when I say it's prime? What are the only numbers that divide into it if it's prime? Itself and 1, yeah. Okay, so let's review real quick how we do bottoms up then, right? Because this is one where we would need bottoms up. Once again, I don't think this is that important because we're not going to do. I'm going to give you a better strategy for stuff like this anyway. Get phones away, please. Phones away. So, how do we do bottoms up then? Remember? We got to find magic numbers, but it's a little tougher this time. What do the magic numbers have to multiply to this time? A times C. Yeah, they got to multiply. So this is in the form A is the number being multiplied by x squared, B is the number multiplied by x, and C is the constant, right? And so they have to multiply to the product of A and C. Well, what's A times C? 44. 11 times 4. So they have to multiply to 44 and add to what? 45. Well, that's pretty easy. What are those numbers? That multiply to 44 and add to 45. 44 and 1, right? So my numbers, positive 44 and positive 1. So then all I do, it starts off looking pretty familiar, right? It starts off looking just like the template we always use. And what are the numbers that I put here to start with? 44 and 1, right? Just like before. But here's where the difference comes with bottoms up. What do I have to do to those numbers? Divide them by A, which is 11. Yeah. So I'm going to divide them by 11. Okay. And then from there on out, it's pretty simple, right? Really just 2 steps. What do I try to do to the fractions first? Try to simplify, reduce them. And then if I can't, I go bottoms up, right? So what does this first factor become then when I simplify? What does 44 over 11 simplify to? Just 4. So we get x plus 4, done. The fraction went away, so that factor's done. Okay, the second one, does 1/11 simplify? Doesn't, right? So we end up with x plus 1 over 11. Because I was stuck with a fraction that didn't simplify, I go bottoms up. So whatever's in the bottom of the fraction goes up in front of the x, and our answer just looks like x plus 4 times 11x plus 1, right? Make sense? Okay. All right, so there's our review, right? If you haven't finished that one up, finish it up. I do think, honestly, and you can be honest with yourself here, is there a chance that some of you are having a little trouble with this just because way back in the day when you were studying multiplication facts, it wasn't as big a deal like it should have been when you were in grade school? And maybe you never got a really solid grasp of your facts. I think it's an easy problem to fix, but I think that's actually something that hampers people in Algebra 2 sometimes. I think it really, in fact, I know it really pays off to have a good grasp of your facts, really up through 15. I think if you know your facts up through 15, man, it makes math so much easier. It really does. It just, that's that number sense part where you can see relationships. A lot of the stuff we're going to be doing in the near future really relies on that. And so I think what I'm going to do is I'm going to put some stuff up on Moodle, or some links to even just some apps, some free apps you can put on your phone, stuff. And this might seem hokey, and maybe it doesn't apply to you. If you feel like you know your facts really well, then try not to do anything. But I want everybody to get to a point where they can, at least through 12, where they can quickly recall their facts. And so we're going to go back old school on this, and I want everybody to be able to knock out a certain number of correct facts, like a time test. And I'll let you take it as many, there's no limit to the number of times you can take it, but I'm actually going to give you a Algebra 2 test grade for this. So this is, and you can do it as many times as you want. This should be a free 100 for everybody. It's not going to be super challenging, but if you can't do it, if you have to think about it that much, that's causing you problems, I guarantee you. And this would be an easy way to fix it. Okay, so I'll put some stuff up there for you to look at, some practice ones to go through. As soon as you can do the practice test, stop studying. Just come in and take the test when we're in the lab and have it done. Does that make sense? That shouldn't be scary, by the way. That's not intended to be scary. It's really just intended to really help you deal with something that's causing you issues, really. And it'll be a free 100%, it should be, in an Algebra 2 class. Okay, what I want to look at real quick, though, that also has to deal with this, and this is the only thing we're going to cover today. How much time we got? Not much time. That's all right. We don't need it. I want to look real quickly at simplifying radicals. Simplifying square roots, specifically. So don't put your stuff away yet. We got 5 or 6 minutes. We'll be done with this, and you can put your stuff away. I want to know, how do I deal with things like this? If I want to simplify radicals, you probably did some of this in Algebra 1, but it's been a while. If I want to simplify something like the square root of 16, that's pretty easy. What's the answer? 4, right? Because 16 is a perfect square, right? That answer is 4. But what if I have something like the square root of 50? That is not going to be just a whole number answer, right? It's going to be, but we can make it simpler. Our goal when we're simplifying radicals is to get as much of the number outside of the radical. In other words, we want to make the number inside as small as possible. Now, the way we do that is we're going to try to find a way to do this, apply this property of radicals. If I have the square root of a product, I can always split that apart into the product of the separate square roots. Okay? Well, why is that useful? Our goal is to see if we can find a perfect square factor of the number, the biggest one possible, and break the number apart into a perfect square times something else, right? So real quick, let's review our perfect squares. What is 2 squared is what? 4. What's 3 squared? 4 squared.
16.
5 squared.
25.
6 squared. 7 squared.
49.
8 squared.
54.
9 squared.
81.
100, or 10 squared, whoops. And we'll go further. I'll have you guys maybe go to 15. And I'll give you this stuff, so you can, the materials where you can just study this stuff on Moodle. I'll give you a list that you can study from, maybe make some flashcards. That's the best way to learn stuff like this. But we want to find out, so what's the biggest one of these numbers that divides into 50? Here's a little strategy that makes this simpler. First of all, see if it's that kind. Is the number itself a perfect square? Well, no, it's not, right? So then that means that if I'm gonna write this as a perfect square times another number, the smallest the other number could be is 2, right? Some number, in this case, it's gonna work out to be 25 times 2, isn't it, right? But you know that the other number has to be at least 2, right? And so all you have to do is just start by looking at half of that number. So half of 50 is 25, so I would only have to look at that part of the list, right? Just start at 25 and work my way down, okay? It works out this time that 25 does go into 50. So we're gonna rewrite this as the square root of 25 times the square root of whatever's left over. Well, 25 times what is 50? 2. So we can split it like that, right? We can write it as the product of a square root of a perfect square times some leftover. Well, the whole point of this is the square root of 25 is what?
5.
5, right? So this looks like 5 times the square root of 2. So we're stuck with a square root, but it's a small one. It's only got a 2 inside instead of a 50, right? Okay, try another one.
Wait, how did you get
Say it again.
it? How did you get it?
Because the reason I picked the 25 is because 25 is 5 squared. So the square root of 25 is going to give me a whole number, right?
But you can still simplify the 2.
How? Square root of 2 I can't do anything with. There's no perfect square that divides into that. The square root of 2 is a decimal. It's like 1.4142, blah, blah, blah. It goes on forever. It never stops. It's irrational, right? So that one, the easiest way to write that is just the square root of 2. Okay, I can't go any simpler than that though, because there's nothing else I can do, right? 2 is not a perfect square, and there's no perfect square other than 1 that divides into it, and 1 doesn't help us. Try another one. How about this? Simplify this one, please. How about square root of 48? Is 48 a perfect square? No. So what's the smallest number? Where would I start looking? Right. If 48 is not, then just take half of that and only look at numbers less than or equal to that. What's half of 48? 24. So all I'd have to do is look at numbers. 24 falls in there. Whoops. Oh, sorry, I do. Paul, you might want to do. Falls in there, so I only have to look at those 3, right? See what I'm saying? Do any of those go into 48? 4 does, yeah. Is there a bigger one? 16. But what if, so is it a tragedy if you don't get the biggest one? We'll see it's not. So 4 does work. We could start with 4. We could rewrite this as the square root of 4 times, well, what's going to be my leftover then? 4 times what is 48? What's it going to be? You're thinking the right thing, is what you said. But 4 times what is 48? In other words, 48 divided by 4 is what? 12. So 12 ends up being my leftover, right? I know what you were thinking. You're on the right track. So if I rewrite that, that becomes 2 times the square root of 12. But is the square root of 12 done? Is there a perfect square that divides into 12? 4 does, right? So I could go one more step, right? I could take this, the 2 part's already done. But what about the square root of 12? We could write that as the square root of 4 times, well, what? 12 divided by 4 is 3. And what's the square root of 4? 2, right? 2, so we end up with then 2 times 2 times the square root of 3, which is really just 2 times 2 is just 4, right? So I've got 4 times the square root of 3. So it worked out. It would have been easier if we would have just seen that 16 goes into 48, right? And we could have written this instead. Right all at once, we could have written it as the square root of 16 times square root of 3, because 16 times 3 is 48, and that just becomes my 4. See what I'm saying? Okay, is that ringing a bell? Is that kind of Remember doing that stuff? We'll look at how to do fractions tomorrow, how to simplify fractions involving square roots, and then I'll give you the rest of the day to work on this stuff, okay? All right. Good stuff.